Good afternoon, and welcome to the 2023 Air Force Research Laboratory Fellows and Science and Engineering Early Career Awards Ceremony. I am Mr. Jeff Duford, and I am honored to serve as one of your Masters of Ceremony today.
And I'm Dr. Darren Raspa, and it's my pleasure to serve as a co-master of ceremony today, and together we will be your guides through this afternoon's festivities. The presiding officials for today's ceremony are Brigadier General Scott Kane, Commander, and Dr. Tim Bunning, Chief Technology Officer.
Please stand for the arrival of the official party, presentation and posting of the colors, and the national anthem, followed by the invocation. Present the colors.
Will you bow your heads and pray with me? Good afternoon, Lord. We thank you for your presence here at the National Museum of the Air Force at this Fellows and Early Career Award ceremony. This afternoon, we are here to honor the best of the Air Force Research Lab. Each award recipient today did not achieve this pinnacle by scrapping selfishly to get to the top of the heap. They got here by being proven leaders and followers, leading by example, and by consistently displaying selflessness and integrity. We all take pride in their achievements because we had a part in their success. And because they have succeeded, we have succeeded. Thank you for family and friends, co-workers and leaders, and for all those who worked so hard to bring us to the culmination of achievement here today. We thank you for those who made great efforts to make today's event stellar. Bless us today. the speakers, the award recipients, and our time together. Make us fruitful as we seek peace and freedom for our world. Thus I pray in your holy name. Amen.
Now, thank you to the Wright-Patterson Honor Guard, to the Air Force Band of Flight, and Chaplain Fussell. Please be seated.
It's now my pleasure to recognize our distinguished visitors attending today. Please hold all applause until after we have recognized everyone. From the Air Force Research Laboratory Command Section, Mr. Timothy Sekulich, Executive Director. Chief Master Sergeant Carlos Labrador, Command Chief. Ms. Alexis Bonnell, Chief Information Officer.
We are also delighted that one of our previous AFRL commanders is able to join us virtually, Major General Retired Heather Pringle. We would also like to welcome all of our Air Force Research Laboratory directors, wing commander, chief scientists, senior scientists, supervisors, AFRL alumni, friends, and families here with us today and attending virtually.
And thank you to everyone that joined us here today at the National Museum of the Air Force and who are out there right now on the internet. Thank you.
Today marks a truly historic moment as AFRL recognizes significant achievement and impact of several individuals and adds their names to a distinguished list.
History is the study of changes over time, and the advances and positive changes you all have made to science and engineering will assuredly have an historic impact upon human knowledge. Please welcome to the podiums our Commander, Brigadier General Scott Kane, and our Chief Technology Officer, Dr. Tim Bunning.
Well, good afternoon, everybody. Good afternoon again to our honorees that I just got to spend a little bit of time with. I just want to say some welcome and some thanks before we get started here today. So our attendees from across AFRL, to include virtually General Pringle. I don't know if you saw Dr. Bunning and me waving to you in the background here, but great to know you're here. But for our honorees today, just another testament to what this means across time and to the most senior leadership of AFRL, just to recognize you. I want to thank the many organizers that what I will say have invented, which is true to AFRL spirit, a blend of a classic formal ceremony that we're doing now and a lot of fun. I have to say, after all, that the reception at the Wandering Griffin after this outsizes the formal part by just a few minutes, so I think we're hitting this right. Thanks to the National Museum of the Air Force for this great venue, the Honor Guard, the Band of Flight, Chaplain for getting us started today. Jeff and Darren for emceeing, and our previous awardees. I see some medallions out there in the audience. Thank you for joining us, and again for your service. I want to thank all the coworkers and supervisors that are here to celebrate. We know that no one excels in a vacuum, so we appreciate your support. And then last but certainly not least, we have a lot of family members here. So I want to thank the family members here today. You're part of this team. I can't thank you enough for your support and encouragement for our honorees today. Just a couple of short words on our workforce, our advantage. And for those that were in attendance at our kickoff of AFRL Discover, which was the previous event celebrating AFRL this week, I mentioned that we have a lot of amazing individuals at AFRL. But that our true success comes from when we work together, cross disciplines, cross our talents, and invent the future. I also mentioned that it's our noble purpose, in this case national defense, that brings us together, that inspires us, that motivates us to do this sometimes very hard work of science and technology. We're in a challenging era, and despite what's dominating the news today, we are in an era of great power competition. And our department and our nation need us to move at an accelerated pace, and this puts a significant demand on you. Demand and pressure on our scientists, our engineers to always be innovating, inventing, exploring, and advancing the state of the art in science and technology so that we maintain our advantages in air and space. So the individuals that we recognize today, 16 scientists and engineers, exemplify that drive. They're no doubt the absolute best of the best, but I'd also argue that they're here because they understand the value of the team, they've demonstrated how to work together, and they no doubt have had an outsized impact on our purpose, our why, which is to win the next fight. So these are individuals who drive the fight. These are the individuals that are really our asymmetric advantage. The 2023 group we'll be recognizing today includes 9 fellows, 7 science and engineering early career award winners. And like I said, science and technology is hard work. It requires a relentless willingness to create, sometimes to fail, to get back up again. And as Dr. Tammy Chalette said yesterday, they provoke, they persist, and prevail. So we're honoring individuals today that have demonstrated that drive. And I'll remind them, I'll challenge them, that I need you to continue to bring that drive to AFRL and to our nation every day. And I look forward to honoring you all today. Thank you.
Yeah, good afternoon, everyone. I'll just add a few remarks as well. I would say being part of this ceremony is truly the best part of my job as the CTO. I've done it now for 3 years, and it's truly, it's an incredible feeling to be up here representing the scientists and engineers that are here, that are in both of these classes, both the fellows and the ECAs. I lead, as the Chief Technology Officer, I lead the solicitation of nominees and then a selection process for both pools. I can tell you that that selection process is very, very rigorous, very, very thorough, very detailed rubrics. I would argue just to be nominated into either of the classes is an honor unto itself. I know when I was Chief Scientist in RX, I always carried that message, that to be honored by being nominated, given the few that we do nominate, is truly a recognition unto itself. And for those that have been selected, you know, kudos to all of you. I too was over at the AFRL Discover event for the last day and a half. I closed it out today around noon. And I looked at that crowd of primarily junior force S&Es who were there. And I had just sat through a technical session where 5 talks in a row, same technical area, one from RH, one from RI, one from RW, one from RV, and one from another TD. There was 5 TDs in a row talking to each other. So to riff on what the boss just said, you know, that is where we need to go as a community in doing, you know, cross TD, cross multidisciplinary work. And so I think the fellows and the ECAs are a primary cog in that ecosystem to help facilitate that going forward. I've always said, those of you who know me, you've heard this 100 times, I've always said the #1 job of the lab is to grow thought leaders. I argue that we influence one of 2 ways. We influence with a checkbook. And a lot of people see AFRL with a $3 billion budget and they want a part of that. But I believe influencing through thought leadership is the more important part of the lab. That is why we have a laboratory. That is why we grow science and technologists. We grow those practitioners that can go out there and, yes, sometimes have a checkbook, but more importantly, they walk into a room, people know who they are. People listen to them because they're at the cusp of both S&T and the operational warfighting regime that we are immersed in every day. And I think the class, the 2023 class, if you look at and read what they have contributed to, both from a S&T perspective, but also the operational impact that it's had. It's truly, truly amazing. I will also echo what the boss said. You don't do this by yourself. First to the families, thank you very much for supporting your folks. A lot of these folks could be off making more money elsewhere. We have a purpose-driven, competent, passionate workforce that is wedded to the mission, and you enable them to stay wedded to that mission. To the supervisors who enable your folks to do the work that they do, kudos for supporting them. And for the teammates, all of them are parts of teams. Thank you very much for supporting them. I know how hard the nomination packages are to prep. I'm sure there was a lot of work behind the scenes through a lot of people to get the folks here to this point. So finally, I'll just end with a couple of stats on ECA. Early Career Award. It's a relatively new award. We started it back in 2012. I'll comment on the Fellow Award when we get to the Fellows. But we really wanted to showcase some of the up-and-comers. And so to be nominated, you have to have been in the government no more than 7 years, and you have to have no more than 15 years since your bachelor's degree. So it's really to try to capture those folks that have come in and done things early in their career, and a lot of times that's centered on being in-house, on the bench, doing S&T, cutting their teeth, growing a technical community. We have had roughly 70 winners since 2012, so we're electing 7 more, so 10% of the ECA class is represented by those folks here. And again, to give you some stats, we probably have 5,000 S&Es with an AFRL. We only nominate 20 of those every year to be a participant. And, you know, like I said, we're going to award 7 of those. So I believe growing that high-quality scientist and engineer who will maintain technical integrity, continue to lead the DAF, not only in areas that we're good at right now, but particularly for the ECAs, you know, with a vision towards where science and technology is going, and where does the DAF need to go to mate that future S&T to where the operators are going to need it in the future. So my congratulations to all of them. I know some of them personally, and others I look forward to getting to know. So thank you.
Thank you, General Kane and Dr. Bunning. We will now recognize our 2023 Early Career Award recipients. Awardees, please come up to the stage when your name is called to receive your award.
Dr. Raspa and I are both historians, so for each recipient, he and I are going to relate a historical tie that has some connection with the recipient. Our first ECA recipient works and leads in the development of brain-machine interfaces, a field in which the labs have long been involved. In the 1960s, 2 notable thinkers performed foundational research and imagined the interaction between the human brain and computers that would be far in the future. In 1960, J.R.C. Licklider, who went on to become a noted computer pioneer, published an influential paper that described in detail and envisioned symbiosis between humans and computers. In 1962, Douglas Engelbart, inventor of the computer mouse and an internet pioneer, published Augmenting Human Intellect, a Conceptual Framework. In it, he described the limits of existing computer interfaces and imagined possible future improvements. He also presciently wrote at the time, "After all, we spend great sums for harnessing nuclear power. Why do we not do the same thing for neural power?" If they were still with us today, I think they would be most impressed at just how far we have risen on their shoulders.
Dr. Nathan Bridges. Dr. Bridges is the primary investigator and program lead for the Individualized Neural Learning System, a joint 7-11 Human Performance Wing, Munitions Directorate, and Materials and Manufacturing Directorate seedling for Disruptive Capabilities Program effort. Since becoming a government AFRL scientist in 2017, he has distinguished himself as a technical and strategic leader in brain-machine interfaces with impact spanning 3 technical directorates and 13 scientific teams of over 56 technical professionals from California to Massachusetts. His research has spanned impact biomechanics, cognitive and behavioral neuroscience, neuroergonomics, neuroimaging, and neuromodulation research domains. Dr. Bridges has also served on 3 Defense Advanced Research Projects Agency programs, represented the United States internationally as a technical expert, directly contributed to the Air Force 2030 strategy, and the establishment of a core research area. Dr. Bridges was nominated to serve on 2 International Institute of Electrical and Electronics Engineer technical committees, and is the founder and chair of the Human-Machine Symbiosis Panel at the IEEE Research and Applications of Photonics and Defense Conference. He's been featured in several popular press articles, a podcast, and is a keynote speaker for the Biotechnology for Defense Conference and upcoming AFRL Inspire event tomorrow. Dr. Bridges also serves as an industry team lead for the AFRL Technology Capabilities Office Explore campaign, overseeing the development of human-computer interface advancements that will enable more effective command and control decision-making. Finally, he was recently competitively selected to serve as a special assistant to the chief scientist of the Air Force. Congratulations, Dr. Bridges. In the history of technology advancement in air and space, it is simply impossible to get away from dealing with heat. If we want to go faster, then propulsion systems and airframes get hotter. And it just gets worse the faster we go. The advent of turbojet engines during World War II demanded metals that could handle much higher temperatures than those in the reciprocating engines they would eventually replace. Worse still, it became apparent that the supersonic speeds projected for future jet-powered aircraft would create intense aerodynamic heating. As a result, after the war, the Air Force's Materials Lab and its partners experimented with titanium, then considered an exotic and difficult metal with which to work. As a result of these efforts, titanium alloys became widely used for applications in high-performance air and spacecraft. For instance, about 85% of the famed Mach 3 SR-71 Blackbird is made of titanium. Titanium also found an important place in enabling more capable jet engines, starting with the J-57 turbojet, which powered the Air Force's first supersonic fighter, the F-100, along with early models of the B-52.
The next recipient is Dr. Todd Butler. Dr. Butler is a senior materials engineer and research leader for metallic materials and processing at the Materials and Manufacturing Directorate. Since 2016, Dr. Butler has leveraged his expertise and visionary ideas to disrupt the status quo for conventional metallic materials, enabling new leap-ahead capabilities for the Air Force. Dr. Butler's research contributions and new ideas have revolutionized the field of ultra-high temperature metals, enabling materials to survive in service environments previously thought to be unattainable. His pioneering concepts, which included 17 publications, 1 book chapter, and 1 patent, have been broadly adopted across the scientific community and in over $20 million of R&D investments across the DoD, Department of Energy, and industry. Through strategically forged collaborations with industry partners, Dr. Butler has accelerated the maturation of state-of-the-art metallic solutions. In addition to his deep materials knowledge, Dr. Butler is an expert in the application of advanced materials characterization techniques. He leveraged this expertise to lead RX's $22 million materials characterization facility, supporting more than 150 stakeholders across the materials and manufacturing, sensors, aerospace systems, and munitions directorates and external groups, while also enabling the design of advanced refractory metal alloys down to the atomic scale. As research leader for metallic materials and processing, Dr. Butler leads a $1 million plus in-house research portfolio with more than 30 civilian scientists and on-site contractors, providing a digital vision for the future, leveraging enhancements in machine learning and integrated computational materials engineering. Dr. Butler is also active in the community through his service to professional and government societies, mentorship of his peers, and future STEM workforce. Congratulations, Dr. Butler. Our next recipient's work is impacting future electronic warfare systems through the efficient generation and transmission of signals. During the Southeast Asia War, the Air Force was faced with a crisis in electronic warfare after the loss of an F-4 fighter to an SA-2 surface-to-air missile, or SAM, in July 1965. The labs quickly responded in multiple ways, one of these being the creation of the first pod-mounted electronic warfare countermeasures jammer. The following jamming pods generated and transmitted signals that interfered with radar-directed anti-aircraft fire and SAM operations. They became so important to operational success that the order went out that no Air Force tactical aircraft were permitted to fly over North Vietnam without carrying at least one of these jamming pods. And such pods remain important systems still in use today.
Dr. Nicholas Miller. Dr. Nicholas Miller's government career in AFRL started in 2017 in the Sensors Directorate as an electronics engineer. He is an internationally recognized expert in two distinct but complementary disciplines, radio frequency and millimeter wave modeling and measurements of advanced transistors and integrated circuits. Dr. Miller's contributions are having significant impacts to future Department of the Air Force radar, electronic warfare, and communication systems that require the efficient generation and transmission of high-frequency signals. His highly innovative and unique measurement system and analysis provided the feedback that resulted in devices doubling power efficiency compared to the prior state-of-the-art. Ladies and gentlemen, Dr. Miller. Radio waves travel by three different routes from their point of propagation to their point of detection: through the troposphere, through the ground, and by reflection off the ionosphere. Our next AFRL Early Career awardee is known for his work in the last of these routes. In 1989, a black spruce forest and wetlands between the Copper and Gakona rivers in Alaska was purchased by the Air Force to use as an over-the-horizon radar facility to observe bombers or missiles that might be headed over the pole. However, the High-Frequency Active Auroral Research Program, or HARP program, would never be used for this purpose, but become home to a field of antennas, first 18 antennas, which would grow to over the years to 180, each powered by two transmitters. It was called the world's largest ham radio that broadcasts high-frequency waves up to the ionosphere. These transmitters were powered by 5 diesel generators, 4 from tugboats and 1 from a locomotive. When activated, the transmitters could send a focused beam of radio wave energy into the ionosphere, 50 to 600 miles overhead. In one study, researchers used the antenna array to heat a part of the ionosphere that in turn acted as a low-frequency antenna that could send an ocean-penetrating signal to a submarine. The legacy of using the ionosphere in novel ways for defense continues in the work of our next early career awardee.
Our next early career awardee is Dr. Kenneth Obenberger. Dr. Obenberger became an AFRL government scientist in 2017 as a research physicist in the Ionospheric Effects Branch of the Space Vehicles Directorate. He has quickly become an internationally recognized leader in ionospheric remote sensing. His research has been foundational to finding and developing the crucial missing links to advance the ionosphere from a research area to a core capability with an articulated military requirement. Additionally, Dr. Obenberger's research addresses 9 of the Space Force's 15 top capability priorities, and he plans to keep moving the ionospheric technology needle from the impossible to the probable. His latest idea uses the ionosphere as a microphone for detecting the infrasound generated by explosives. Through his novel approach, he has achieved clear detections of explosions roughly 1,000 times smaller than previous capabilities. He has also developed novel techniques for passive ionospheric remote sensing that leverage radio noise from lightning and power lines, resulting in 1 awarded patent and 1 pending. Dr. Obenberger is developing these passive sensing techniques to be used in operational DoD models of the real-time ionosphere. In his 6 years as an AFRL scientist, he has authored 14 peer-reviewed journal articles and 34 conference proceedings, and he has been a team member on 2 flight experiments and 9 field experiments. He has deployed experimental sensors on 1 Navy ship and 2 Coast Guard cutters sailing in both the South Pacific and the Caribbean Sea. Congratulations, Dr. Obenberger. Our next recipient is on the leading edge in developing compact, high-frequency electronics. The Air Force Office of Scientific Research made key contributions to the development of compact electronic components. In the 1950s, at a time when clunky, unreliable vacuum tubes remained in widespread use, AFOSR funded early microelectronics studies. In addition, AFOSR-funded scientists engaged Dr. Jack Kilby, the inventor of the integrated circuit, to apply this new technology to Air Force needs and requirements. To illustrate just how big of a leap this was, a demonstration in 1961 showed that only 587 integrated circuits could replace 8,500 transistors, saving considerable space, weight, and power. In 1962, the Air Force's Minuteman II ICBM became the first American military system to employ the revolutionary integrated circuit.
Dr. Michael Page. Dr. Page is recognized throughout the Department of Defense as the leading expert in multiferroic materials for high-frequency electronics. His deep technical expertise in the complex physics underlying magnetic dynamics has been a critical element in his successful establishment of an extensive research portfolio in multiferroic materials, spanning the synthesis of world-class materials, an unparalleled suite of characterization tools for studying dynamics and identification of exotic magnetic phenomena poised to create state-of-the-art technologies, which has resulted in more than 40 peer-reviewed publications and multiple patents. He has also dedicated himself to transitioning technology to the warfighter. His discovery of the ability to control the propagation direction of surface acoustic waves through interaction with an engineered magnetic material creating an acoustic diode has revolutionized this important technology, enabling a new paradigm of compact high-frequency electronics critical to future Air Force information, surveillance, and reconnaissance and electronic warfare technologies, which are crucial to operating in near-peer conflicts. Dr. Page has leveraged these discoveries into programs to transition technology to solve real challenges, as evidenced in his role as Directorate Lead for One Seedling for Disruptive Capabilities Program, project on moving beyond motor control in Air Force operations using advanced neural interfaces to accelerate learning, and his AFRL lead of the wideband agile RF communications for high-altitude modular platforms SDCP. Throughout Dr. Page's career at AFRL, he has embodied the quintessential civilian scientist by strongly leading the community to meet the needs of the warfighter. Dr. Page, everyone. Our next early career awardee is known for his work in pulsed power. The year was 1963. And the Limited Test Ban Treaty had just gone into effect, limiting nuclear testing in the oceans, atmosphere, and outer space, when Headquarters Air Force first proposed the creation of AFRL predecessor, the Weapons Laboratory, on Kirtland Air Force Base in New Mexico. Their mission? nuclear effects data, microwaves, and laser R&D. Just a few years after AFRL's founding, Captain Bill Baker and First Lieutenant Peter Turchi set up a new and vitally important simulation project. Their job was to design and build a machine which could produce X-rays similar to those generated during a nuclear explosion. Data from such a device would be extremely useful to evaluate the vulnerability and survivability features of numerous Air Force systems. After deliberating for some time, Baker and Turchi decided to name the machine Shiva, in honor of the Hindu god of creation and destruction. With its 6 120-foot-long, 10-foot-high pulsed capacitor arms radiating from the center of the machine, Shiva helped assure nuclear survivability for defense systems. The program pioneered the use of MJ-class pulsed power systems for simulation of the X-ray radiation environment from a nuclear detonation. With its microsecond rise time, Shiva was a laboratory stepping stone to facilitate load development for pulsed power, work that continues to this day in the work of our next early career awardee.
Our next awardee is Dr. James Schrock. Dr. Schrock, a former Air Force officer, currently serves as the technical advisor for the High Power Electromagnetic Technology branch of the Air Force Research Lab's Directed Energy Directorate. Across his career at AFRL, he has held numerous roles, including Section Chief for Computational Physics and Principal Investigator for the Counter-Electronic Non-Kinetic Microwave Attack and the Electromagnetic Weapons Technology programs. Through his leadership, he established wide-ranging research projects with national laboratories, the Department of Defense, industry, and academia, and which provided high-power microwave weapon solutions to warfighting technology gaps. Dr. Schrock has distinguished himself in the fields of prime power, pulse power, solid-state radio frequency or RF sources, and RF biosafety. For his accomplishments, he has received 12 professional awards for outstanding technical achievements. In his external committees and professional societies roles, Dr. Schrock is internationally recognized as an expert in high-power electronics and electromagnetics. He is currently a senior member of the Institute for Electrical and Electronics Engineers and an elected member and secretary of the IEEE Pulsed Power Science and Technology Committee. He serves on conference organizing committees for IEEE Pulsed Power conferences and the Directed Energy Professional Society. He authored 6 journal publications, 6 conference proceedings, and is a co-inventor on 3 patents, 2 of which are pending. His technical leadership is enabling next-generation high-power microwave weapons for base defense, aircraft protection, and clandestine strike missions. Congratulations, Dr. Schrock. Intelligence, surveillance, and reconnaissance, or ISR, has been the foundation for all military operations in war for centuries. Knowing your adversary's capabilities, order of battle, and intent often spelled the difference between victory or defeat. This is no less true in the orbital environment, the realm of ISR that is our next early career awardee, in which he has performed his phenomenal work. In 1957, Sputnik shocked and terrified the free world. Less known that year, Russia also launched an ICBM. A nuclear attack was possible, and we desperately needed a way to monitor the Soviet Union's missile activity. The U-2 program began in 1954, making it the first of these new surveillance programs intended to fully inform national leaders about Soviet activity and this threat. The aircraft flew at about 70,000 feet, high enough, it was believed, for the plane to be beyond the reach of Russian air defenses. As we know, that bubble burst on 1 May 1960, however, when a U-2 piloted by Francis Gary Powers, conducting a reconnaissance mission high over Soviet territory, was suddenly struck by a Russian SAM and Powers was downed. We needed to go higher. President Eisenhower and the Air Force had another solution: space-based surveillance and reconnaissance. The Corona program began in 1961 to create amazingly complex imaging satellites. In 1963, Gambit provided the highest resolution imagery yet from space. Hexagon, a few years later, was a replacement for Corona, providing more persistent imagery and packaging 60-mile rolls of light-sensitive film in 4 return vehicles. Air Force work in pushing the envelope of space ISR continues to this day in the work of our next early career awardee, Dr. Preston Webster.
Dr. Webster joined the AFRL government workforce in 2018 as a research electrical engineer. Currently assigned to the Space Vehicles Directorate at Kirtland Air Force Base in New Mexico, he led the establishment of space vehicle research expertise and molecular beam epitaxy growth of underlying infrared materials that functionalize space ISR systems and investigates novel sensing strategies. He has published 38 peer-reviewed articles, 61 conference presentations, 1 book chapter, and 1 issued U.S. patent with another patent pending, all developed with a strategic goal in mind to ultimately bring his various research efforts together to yield a transformative capability. The culmination of his work to date has led to his recent award of a cross-directorate seedling for Disruptive Capabilities Program, which he leads as its principal investigator. These accomplishments have largely been enabled by the diverse array of partnerships that Dr. Webster has stood up to support his space sensing research, including small business innovation research programs, partnership with Sandia National Laboratories, and cooperative agreements with several universities across the Southwest United States. Dr. Webster's university partnerships have been particularly critical, as much of his team is composed of master's and PhD students whose sensor material and sensing concept research efforts concurrently contribute to their thesis material. In the process, Dr. Webster has served on the graduating committees of 8 graduate students and advised 3 uniformed S&Es in their research at AFRL. Dr. Webster, everyone.
At this time, we invite General Kane and Dr. Bunning to say a few words before we induct the 2023 class of AFRL Fellows.
All right, we're gonna even top that, which was amazing. That was a great start, and now we're going to recognize our 2023 AFRL Fellows. So a little background on the program. The program recognizes outstanding scientists and engineers for exceptional AFRL career achievements, spanning research, technology development, demonstrated tech transitions, and organizational leadership. The men and women selected as fellows join an elite group that represents 0.3% of the AFRL professional technical staff. There have been 251 total AFRL Fellow recipients since the program started 37 years ago. Each new AFRL Fellow receives a research grant along with a medallion and a prominent display in the AFRL headquarters, which I will tell you I stop and read that display often on my way to my office. Our fellows have been tackling science and engineering challenges for many years, and I talked about provoke, persist, and prevail before, but these individuals are the epitome of persist and prevail. Not only does this award represent a culmination of a career of excellence and accomplishment, it signifies that you are among our most relied upon and trusted technical leaders. And in your careers, the tech space and the nature of tech competition has changed quite dramatically. Now you lead us in a rapidly evolving age where information, digital technology has changed everything. And the ability to navigate this change, and in some cases you are driving this change or have driven this change, and to continue to invent the future is absolutely remarkable. So congratulations to all our to all our AFRL fellows. They will very likely humbly give credit to opportunities that they've received along the way, mentors they've had, and being part of an incredible organization as the keys to their success. And while we appreciate that support you've had along the way and agree this is a incredible organization, this is our chance to celebrate you, and you should take a moment just to be proud of what you have accomplished. We're all proud and thankful for all of you.
Yeah, I too want to congratulate the group. Not knowing what the boss was going to say, I'll be very quick because he took some of what I was going to say, which is all good. Real quickly, 3 categories. I think sometimes people lose sight of this. Sometimes people think of this as an S&T Science Award, who wrote the most papers. But there are 3 separate categories. One is in research, one is in tech transfer and tech transition, and one is in organizational leadership. But it's really technical organizational leadership. It's not that you were a division chief for 10 years or you had a title. It was that you led an ecosystem. When I think of the fellows, and this is going to date me, I think of an old commercial that used to be on TV. And I think some of you will recognize this, but there used to be a commercial that was for E.F. Hutton. Some people know about this commercial, right? And so whenever E.F. Hutton was being said in circles, everyone would stop and listen. And that is really the epitome of what I think our fellows are. Yes, maybe they've controlled resources through the years, but more importantly, they're a cog in a larger S&T ecosystem. The folks that are in that ecosystem know them. When they walk in a room, they're looking to interface with them, not, again, because they have a checkbook, but because they are the world-leading experts in those areas. And that's what we want out of thought leadership within AFRL. I've also said this in previous fellows ceremonies, and I'll say it again here. And I'm a jack of all trades, master of none. And because of that, I've had the honor of participating in a lot of other professional society activities. I've changed my careers through the years, and because of that, I've participated in a number of different technical professional societies. So I have a feel of how those individual professional societies, how hard it is to become a fellow within each of those societies. I will tell you without a doubt, it is harder to become an AFRL fellow than just about any professional technical society. So it really gives you a sense of the bar of the bar of the talent that we have coming in. So I look forward to inducting the 9. I look forward to working with them in the future, and let's get on with the ceremony.
Thank you, Brigadier General Kane and Dr. Bunning. We will now induct the class of Air Force Research Laboratory Fellows. Each fellow, please come to the stage as your name is called. Our first fellow has provided unifying leadership in advancing and applying additive manufacturing technology. At the end of World War II, noted scientist Dr. Theodore von Karman led an extensive technology assessment and forecasting study called Towards New Horizons, which comprised several volumes. Volume 4, Aerodynamics and Aircraft Design, wisely stated, quote, "It is almost impossible to consider materials without paying attention to production processes," end quote. So it is no surprise that AFRL contains the Materials and Manufacturing Directorate today. A modern production process, additive manufacturing, revolutionized manufacturing, creating unprecedented speed, efficiency, and flexibility. Additive manufacturing relies on computers, and in this respect, the lab developed foundational technology in the 1970s and early 80s on the path to today's additive manufacturing capability. The Materials Laboratory Manufacturing Technology Division, known as ManTech, stood up and led the Air Force Computer-Aided Manufacturing Program and the following integrated computer-aided manufacturing program. These efforts were timely catalysts for modernization and the revitalization of the aerospace manufacturing base at the time.
Our first fellow is Dr. Mark Benedict. Dr. Benedict is currently a Principal Materials Research Engineer in the Materials and Manufacturing Directorate with 26 years of service within the federal government and serving in AFRL since 2014. He is a world-renowned researcher in the area of additive manufacturing with particular contributions in the areas of open source AM, standards qualification, and certification methodology. He currently serves as the Chief Technical Advisor for the America Makes National Manufacturing Innovation Institute, helping to plan, define requirements for, select, and monitor execution of the $446 million technical portfolio that American Makes has in the area of convergent manufacturing over the last decade. Additionally, he has directed a research portfolio in excess of $50 million annually in AFRL funds focused on advanced and convergent manufacturing. His decade in additive manufacturing has ushered in profound acceleration of its adoption in DoD, industry, and academic settings, with many parts flying on platforms such as the A-10, F-22, C-17, and F-16 due to his contributions. His combination of diverse technical expertise, national strategic vision, and team building postured the Department of the Air Force as a national leader for the adoption of additive manufacturing. Dr. Benedict contributed to the Department of the Air Force, Office of the Undersecretary of Defense for Research and Engineering, and national strategy, policy, and technical standards related to additive manufacturing. Congratulations, Dr. Benedict.
Part of our next fellow's achievements involved the development of highly capable phased array radar antennas. Phased array antennas operate by electronic scanning in lieu of physically moving radar dishes, and the Air Force's labs helped advance this revolutionary technology. The Rome Air Development Center pioneered ground-based phased array radars in the defense of the United States. And numerous programs in the Air Force avionics and material laboratories advanced active electronically scanned phased array, or ESA, antenna technology for aircraft. In 1964, the Molecular Electronics for Radar Applications program used silicon microwave integrated circuits to prove the practicality of ESA antennas. In following decades, these labs continued to reduce the size and increase the reliability and capability of phased array systems through such programs as the Reliable Advanced Solid-State Radar, Electronically Agile Radar, and the Solid-State Phased Array, leading to the highly capable systems in operation today.
Our next fellow is Mr. Thomas Dalrymple. Mr. Dalrymple is a principal electronics engineer within the Sensors Directorate. He has been an AFRL government engineer for 20 years. He is an internationally recognized authority in advanced microelectronics and radio frequency, or RF, components, scalable phased array antennas, and digital RF system technologies. Mr. Dalrymple's extensive experience in commercial electronics packaging led to innovations in scalable phased array architectures that span ground, sea, air, and space-based applications. His revolutionary in-house research in wideband digital beamforming technology established the groundwork for subsequent development and successful transition to many of our most advanced military radar capabilities. Mr. Dalrymple built the business case for over $400 million in external investments in advanced microelectronic components for electronic warfare receivers and advanced sensors. He also established lasting partnerships throughout the Department of Defense and beyond, and solidified plans with multiple transition partners to drive future Department of the Air Force capabilities. From mentoring future researchers to advising senior DoD decision makers, his accomplishments and impacts are comprehensive, profound, and highly impactful. Congratulations, Mr. Dalrymple. One of the most difficult tasks on orbit is tracking and rendezvousing with another spacecraft. Our next fellow being honored is known for his work in vibration mitigation for space sensors and precision guidance and control for spacecraft rendezvous and proximity operations. In 1965, the Gemini program was in full swing. Project Gemini's mission was to build upon Mercury and further prove the techniques needed in rendezvous and docking techniques required to implement the lunar orbit rendezvous method that NASA had chosen for the moon landing missions. On 16 March 1966, the Agena target vehicle launched with astronauts Neil Armstrong and Dave Scott in the Gemini 8 spacecraft an hour and a half later, and once on orbit, Armstrong and Scott chased down the Agena, their goal to perform the world's first on-orbit docking with another spacecraft. It was like an air-to-air refueling mission from hell. Only in space, if you powered down the thrust, the nose of your bird kept on going at full speed towards the fuel probe hanging from the back of the tanker. Not only did you need to be an ace pilot astronaut, your spacecraft and sensors had to be able to withstand quite a bit. Those ace pilots were Dave Scott and Neil Armstrong, and the sensors had been researched and developed by Weapons Lab scientists and engineers on Kirtland Air Force Base. The docking was successful, and the sensors and ship handled the shock perfectly. Almost. Although the mission is more famously known for the uncontrollable spin that almost killed Armstrong and Scott, the work of our lab personnel had proven the possibilities of spacecraft rendezvous and proximity operations. That legacy continues in the work of our next fellow being honored today, Dr. Richard Scott Irwin.
Dr. Irwin has spent 30 years of government service within AFRL Space Vehicles Directorate. He's an internationally recognized leader in the areas of active and passive vibration mitigation for space sensors and precision guidance and control for spacecraft rendezvous and proximity operations. His research activities have included a spectrum of technologies, including sensor network management, active structural control, satellite communications, and spacecraft guidance and autonomy. Dr. Irwin's specific contributions include the development of new vibration control and spacecraft maneuver control algorithms, the validation of new technologies related to these applications on orbit, and principal investigator responsibilities for 5 on-orbit spaceflight experiments collectively valued at over $250 million and involving mission partners from across the entire national security space enterprise. Dr. Irwin has been recognized by multiple professional societies for his contributions and his service, previously being elected to Fellow of the Institute of Electrical and Electronics Engineers and the American Institute of Aeronautics and Astronautics. He has served on advisory committees for multiple university academic departments, as well as review panels for institutions including Sandia National Laboratories and the U.S. Space Force's Space Systems Command. During his career at AFRL, he has personally mentored over 80 interns, postdoctoral researchers, and visiting faculty, and has overseen outreach efforts such as the AFRL University NanoSat program, the participants of which are now leaders in academia, industry, and government. Congratulations, Scott. Our next fellow's work addresses the longest demand for more powerful computers to meet Air Force requirements. Such a need existed in the 1950s when the U.S. faced the threat of nuclear-armed Soviet bombers. At the time, the Air Force required but lacked an automated air defense system. Moreover, such a system necessitated technology that didn't even exist at the time. The labs partnered with the Massachusetts Institute of Technology, better known as MIT, of course, which stood up the now famous Lincoln Laboratory to solve this ominous and daunting problem. The resulting semi-automatic ground environment, or SAGE, air defense system operated from the late 1950s to the mid-80s. The first major application of computer-based automation to solve an Air Force problem pioneered many new technologies, including real-time computing, interactive displays, computers linked by modems through telephone lines, magnetic core memory, and controlling aircraft via data links.
Our next fellow is Dr. Grace Metcalf. We know where the AFOSR people are. Dr. Metcalf has been a government scientist for nearly 16 years, with 6 of those within the lab. She's currently assigned to the Air Force Office of Scientific Research as lead program officer for the Quantum Information Science portfolio, where she leads through action in defining and shaping national and international policies and programs while creating powerful interagency and global alliances. Dr. Metcalf is actively recruited to serve on several panels, including multiple interagency quantum information science working groups for the White House Office of Science and Technology Policy, or OSTP, which led to 4 publicly released OSTP policy documents on quantum information science. Appointed by the Office of the Secretary of Defense, Dr. Metcalf also currently leads U.S. efforts in quantum information processing under Australia, UK, U.S. collaborations. Dr. Metcalf's leadership in interagency and global engagements markedly promoted the critical role of AFRL in QIS-based revolutionary advancements in sensing, computational, communication, and security capabilities impossible through conventional means. Dr. Metcalf's continued efforts in seeding and promoting cross-technical directorate collaborations have also streamlined AFRL-wide QIS initiatives across the 6.1, 6.2, 6.3 spectrum, accelerating technology transition like the Quantum Accelerator and Quantum Collider events. Dr. Metcalf has procured and managed almost $200 million above and beyond her core AFOSR portfolio, and is also a profound researcher with 3 patents, numerous refereed publications, book chapters, technical reports, and conference proceedings, and she has delivered over 150 conference and seminar presentations. Congratulations, Dr. Metcalf. Well, Dr. Rasp and I had the pleasure of hosting last year's AFRL Inspire, and our next fellow being honored was one of the early individuals to be profiled at Inspire back in 2017. In his talk, our next fellow highlighted Newton's 1704 description of the limitation on telescopes in his treatise Optics, in which he noted that telescopes cannot be performed as to take away the confusion of the arrays which arise from tremors in the atmosphere, which we now know as atmospheric turbulence. In 1953, Horace Babcock would publish an article describing a concept for compensating for astronomical turbulence that would be realized 30 years later in an isolated area of Kirtland Air Force Base. The Starfire optical range had long been utilized as a test site by various agencies dating back to the 1950s, and in 1969, the Atomic Energy Commission entered into an agreement with the Air Force Weapons Laboratory to allow construction of an optical test range to support beam propagation and effects research for high-energy lasers. One of the first test devices was a field test telescope designed to point a high-energy laser beam generated by the Air Force Laser Program at various static and moving ground targets to support the work of the pioneering Air Force Laser Lab program, which was the first airborne platform to shoot down air-to-air targets, to successfully aim, track, and disable a long-range air-to-air target, and the airborne laser had to compensate for atmospheric disturbance. This was also needed to clear up the twinkle in the stars to get a better view of our orbital assets. The adaptive optics technology that was developed back then to increase our space domain awareness was due to both the pioneering work of Dr. Robert Fugate as well as the work of our next fellow.
Dr. Dennis Montera. Dr. Montera has been with AFRL since 1996 and a government employee for 35 years, and now serves as a Starfire Optical Range Principal Investigator in the Directed Energy Directorate. Space is now a contested warfighting domain, making ground-based S&T for space domain awareness a critical area in defense of our national interests. Dr. Montera established and matured a groundbreaking space domain awareness portfolio at the Air Force's premier optical observatory, the SOR, achieving and transitioning laser guide star adaptive optics into practical, engineered systems that directly answer the operational needs of the Space Force and Air Force. Dr. Montera's 25 years of scientific excellence have led to at least 5 world-leading, first-ever scientific accomplishments in the areas of remote optical sensing, high precision, high frame rate tracking, adaptive optics, and beam control. His accurate models of demonstration systems have given senior decision makers in the DoD the confidence to make decisions to start programs of record for additional fielded capabilities. Throughout his career, Dr. Montera has successfully tackled key scientific challenges in the field of adaptive optics as it relates to ground-based electro-optical systems for space domain awareness. Dr. Montera has transitioned multiple AFRL technologies to Air Force, Space Force, and other DoD organizations, both while in uniform and as a Department of the Air Force civilian. And in the process, he has changed the landscape for these critical technologies. His persistence and dedication to making these efforts successful are part of why AFRL is the premier force in the scientific world. Ladies and gentlemen, Dr. Montera. Our next fellow's work involves understanding how materials behave in dynamic circumstances. Such knowledge became an important focus for the Air Force in 1969 after the unexplained structural failure of an F-111 at low altitude that killed its veteran crew and grounded the F-111 fleet. The ensuing investigation discovered that the crack in the attachment plate, which caused the F-111's wing to fail, could not have been detected using existing inspection technology. In response to this problem, the Materials Laboratory launched a significant initiative to improve non-destructive inspection and evaluation capabilities. This effort produced advanced ultrasonic computerized axial tomography, or CAT scanning, and magnetic particle inspection technology that increased aircrew safety and decreased the likelihood of such tragedies reoccurring again.
Our next fellow is Dr. Michael Uchik. Dr. Uchik has 25 years of service in AFRL and currently serves as Principal Materials Research Engineer and Research Lead in the Materials and Manufacturing Directorate's Materials State Awareness Branch. He is an international authority on advanced experimental methods and the accompanying digital workflows to enable quantitative 3D characterization of material microstructure and the fundamental understanding of micromechanical behavior of aerospace structural materials. A significant portion of Dr. Uchik's career has been dedicated to inventing and maturing new experiments that provide high pedigree input and validation data to support digital materials engineering practices in the Department of the Air Force. Dr. Uchik led the development and adaptation of automated microscopy systems to solve foundational Department of the Air Force measurement challenges in measuring the microscopic features and defects that comprise materials over vast length scales. He is also credited with groundbreaking advances in the measurement of materials properties through the invention of microscale testing methods, and the subsequent discovery of small-scale effects in metal deformation. The initial research on size-scale effects by Dr. Uchik and co-authors Dr. Dennis Dimiduk, Dr. Jeff Florando, and Professor William Nix was published in the journal Science and has over 2,600 citations. This research spawned revolutionary advancements in the understanding and prediction of material behavior at the micro scale. Furthermore, the microcompression method invented by Dr. Uchik and colleagues is a worldwide standard for material deformation studies, discovery, and screening of new materials, and testing of microscale objects. Congratulations, Dr. Uchik. Among his many achievements in explosive science, our next fellow possesses unparalleled expertise in fusing technology, which is a critical element in achieving desired kinetic effects against targets. When the Air Force was faced with increasing numbers of hardened and buried targets, the munitions lab pioneered accelerometer-based penetration fusing technology as part of the solution. The Hard Target Smart Fuse program of the 1990s demonstrated a device that could sense concrete, soil, and air in real time to detonate when it reached a void, which would be the likely location of the target. Follow-on programs developed even more capable fuses that could sense multiple voids and depths, which supported multiple warhead events, all while surviving the intense shocks involved in penetrating hardened material at high speed. Such advances have dramatically increased our kinetic strike capabilities.
Dr. Eric Well. Dr. Well is a principal mechanical engineer in the Munitions Directorate and has more than 14 years of government service in AFRL. Dr. Well represents the epitome of a technical and transformational leader, having moved his basic research in science and technology developments to solve long-standing challenges in explosive initiation and reactive flow sciences, while transitioning knowledge, models, and designs to Air Force programs of record and the broader technical community. He is a renowned visionary, researcher in the S&T niche field of explosive science, respected as having an entrepreneurial mindset coupled to unparalleled expertise in detonation physics, weapon initiation and fusing technologies, digital engineering of explosives, and scale bridging models focused on weapons. He realized his impact for our mission by pursuing a holistic view to the generation of knowledge and transforming it into technology for our national interest. He has done this through research, DoD policy updates, laboratory infrastructure development, researcher development, collaborations, and business approaches. As an example, a model-based engineering approach for weapons requires the use of appropriate models, which in turn rely upon key data. Dr. Well successfully advocated for updates to DoD qualification guidance for explosives to collect the necessary data. A practical obstacle to collection of this data is association cost. In response to this obstacle, he then invented and patented technology to enable the economical collection of the data. That technology is now being deployed to peer DoD laboratories and the UK's Ministry of Defence. Dr. Well, everyone. Every parent out there knows and perhaps dreads the earth-shaking question that must issue forth from their child's mouth one day, usually a day sooner than you'd imagine, and that question is this: where do I come from? Now, the answer to that could come in various forms, from the mythological to the anatomically mundane, and may fall within a spectrum of uncomfortableness on the part of the parent. As a historian and a dad, I have experience both in answering this question for 7-year-olds and adult scientists and engineers who may be curious about their organizational origin story. Now, the origins of our next fellow's work began in the earliest origins of the lab's space weather work, dating back to the Cambridge Field Station in 1945. The earliest predecessor to our modern Space Vehicles Directorate, their work involved analyzing the sun and the region above the troposphere using radio astronomy and high-altitude balloons, launched from across the country from the lab at the time in a remote place called New Mexico. The data collected including near space pressure, temperature, and the radiation environment caused by cosmic rays from stars, including our own sun. In the late 50s and 60s, in tangent with the Aeromedical Field Lab at Holloman, Cambridge lab scientists developed cosmic ray balloons to measure the electromagnetic radiation environment of the upper atmosphere and to determine how large a dose a human being and spacecraft could safely receive when on orbit for the early space program. This work in analyzing the radiation of space would continue through the Space Technology Center days of the 1980s, the Phillips Lab days of the 1990s, and continues in the work of our next fellow, Dr. Stephen White. Dr. White is unable to be here today, and accepting on his behalf is Dr. Timothy Bunning.
Okay. In 2009, Dr. Stephen White started his government service career at AFRL as a senior research radio astronomer in the Space Vehicles Directorate. Dr. White works on the study of solar phenomena that can impact DoD operations and on the basic physics of the solar atmosphere, including solar radio bursts that can affect GPS location ability and the sources of solar energetic particles. He has helped to enable the observation of the sun, a very bright radio source, by state-of-the-art international radio telescopes that are designed to observe much fainter cosmic sources, but have capabilities that are often superior to solar-dedicated instruments. Radio data can be combined with multi-wavelength satellite and ground-based observations to better understand the sun's behavior and its impact on the Earth. His contributions have advanced the understanding of natural space weather disturbances driven by the sun that can affect communication and navigation satellites. Dr. White's scientific advancements while at AFRL have been reported in over 80 peer-reviewed journal articles, 150 conference presentations, 13 technical reports, and 29 committee reports, of which 6 are national strategy policy reports. He has been the principal investigator on 16 research grants. He has a wide range of national and international collaborators serving as co-investigator on grants involving 10 different countries and 12 different U.S. agencies and universities. And a round of applause for Dr. Stephen White.
I used the term noble cause before, or maybe another way of saying it is dedication to his field. So Dr. White is currently in a telescope on the top of Maui, coordinating a series of experiments with a couple of other telescopes from around the world. These things are planned out months and years in advance, and it was a debate of coming here or following through with the experiment, and I think he made the right choice, being an alpha nerd myself, so that's why he's not here.
And thank you, Dr. Bunning. Over 10,000 feet above the Pacific Ocean, on the top of a volcano on the island of Maui, there are 3 subjects of note. 1, the Air Force Maui Optical and Supercomputing Site, or AMOS, which has provided the U.S. Department of Defense with space situational awareness capabilities for decades. 2, the Maui Space Surveillance Complex. And 3, if you had been fortunate enough to be present not too long ago, our next fellow dancing the hula. That would be Dr. Raspa's words. No joke, it's in her bio. In 1951, amateur astronomer Grote Reber looked up to the peak of the volcano high above Maui and recognized its potential as a site for optical R&D. 4 years later, in 1955, Dr. Walter Steger from the University of Hawaii Department of Physics conducted a site survey near the summit of Haleakala. Thank you very much. Never been to Hawaii. To determine the suitability of the location for a solar observatory. Soon after, the Smithsonian Astrophysical Observatory selected this location as one of the 12 sites for its global network of 12 Baker-Nunn telescope camera systems dedicated to tracking the Vanguard satellite. At the Smithsonian's request, Dr. Mies, former Vice President for Research at the Eastman Kodak Company, provided financial support to build a small satellite tracking station at this location. Prior to the establishment of the optical station, the site held roles as a star tracking project, a satellite tracking facility, a meteor tracking facility, and in 1961, the Advanced Research Projects Agency, known as DARPA today, initiated the ARPA Mid-Course Optical Station Program, the origin of the AMOS acronym with the goal of developing an astronomical quality observatory to obtain precise measurements and images of satellites, payloads, and other space objects. In 1993, the Air Force renamed AMOS the Air Force Maui Optical and Supercomputing Site, a name it has kept to this day. Our next fellows' work there would continue the AFRL imaging breakthroughs that stretched back to the early days of the Cold War.
Dr. Stacy Williams. With 13 years of service in AFRL, Dr. Williams is the first ever Air Force Office of Scientific Research space science architect responsible for directing new space-related efforts to align critical basic science with United States Space Force mission needs. She also works closely with the Space Force Deltas to ensure that AFOSR-sponsored research is transitioned to meet the evolving needs of the force. Early in her AFRL career, she was instrumental in preventing the closure of AFRL's unique world-class Air Force Maui Optical and Supercomputing Research Facility, a major accomplishment that set the stage for a career positively impacting the Department of the Air Force's space mission through S&T innovations. At Maui, she was the first to leverage the operators in the research mission by creating a blended operations and R&D approach to technology development. This novel approach led to very rapid transition of AFRL-developed technologies in support of space operations, including the world's best 24-hour imaging capability of satellites in low Earth orbit. Dr. Williams is an internationally recognized thought leader. She has served on several White House and Office of Secretary of Defense interagency working groups, developing policies that affect space S&T. She has organized international conferences and chaired sessions to encourage technical exchanges and inspire research toward Department of the Air Force future capability needs on a global scale. Dr. Williams, everyone. Ladies and gentlemen, our 36th class of Air Force Research Laboratory Fellows. At this time, we invite General Kane and Dr. Bunning back to the podium for closing remarks.
Well, one of our honorees, one of our ECAs, as they walk by the stage here, mentioned that this is a great backdrop for the ceremony. And I was even talking about this with some of the families beforehand, before coming out here, and I cannot help myself when I do a ceremony in this museum, but to just see all the technology around me and to reflect on the work. I talked about the hard work of S&T, but the work that it takes in science, technology, engineering, testing to do this. It's an incredible force for our nation, and it really, truly has put us where we are today and made us the nation that we are today. And on demonstration here in front of us is an incredible example of the people, the organization that makes this happen. So I've been just inspired to be here. It's been a wonderful ceremony. I'm in awe of your work. I'm proud of all of you. It's a lot of emotions at once for a fighter pilot. But it's truly an incredible event, and thank you all. Thank you all for being here and joining us today. It's a great crowd. We're going to continue this celebration after this at the Wandering Griffin, so I hope a lot of you can join us there today. So thank you all, and I'll see you at the next part of the event.
Before we close here, we would like to extend special thanks to the people that enabled this ceremony to be a great success. This year's banquet planning and execution team, which consists of the following: the entire AFRL Commanders Action Group, with a special call out to Ms. Alexandra Lash and Ms. Shannon Ty, the Office of the AFRL Chief Technology Officer, and from the AFRL Public Affairs Directorate, Mr. John James, Mr. Randy Palmer, Carlos Piniero, Ms. Justin Hayward, Mr. Mike Busher, Mr. Keith Lewis, and Mr. Ryan Law. A special thanks to the AFRL Protocol team, and shout out to Mr. Omar Alvarez Camacho, the AFRL Research Advisory Council, our staff of volunteers, our proffer, Airman First Class Brandon Smith, nice job, and our Masters of Ceremony, Dr. Darren Raspa.
And my buddy Jeff DeFord. This concludes the formal portion of our ceremony. Please stand and join us in singing the Space Force and Air Force song, and remain standing for the departure of the official party. Elizabeth front line is brave and true. Only to space, there's no limit to our sky. We guard both day and night. We're the Space Force from on high. Off we go into the wild blue yonder, climbing high into the sun. Here they come, giving the queen our thunder. Adam boys, give her the gun, give her the gun. How do you know, turning the place from under, off with one hell of a roar. We live in fame or go down in fame. Hey, nothing can stop the U.S. Air Force. Thank you all for attending, and have an outstanding Air Force Day.